All right, so we're going to continue solving here on page 273. We're still solving from 0 to 2 pi. This is number 18, as in Peyton Manning. This is 2 secant of x plus 1 is equal to secant of x plus 3. All right. Isolate the trig function. So we have a treat. See, recall, if you had 2x plus 1 is equal to x plus 3, way back in basic algebra, the first thing you would do is combine the variables, right? You subtract x to this side of the equation. Well, our variable, think of our variable is not x. Our variable is secant of x. You have 2 secants on the left, you have 1 secant on the right. You can combine the secants. Here that falls out. 2 secants minus 1 secant is 1 secant left. And we're very close to what we had before. Isolate the trig function. So in this case, subtract the 1 across. Now, we're at a new place. I don't think we've really discussed this before, so this is fortuitous. Now we're going to talk about how do you solve secant, cosecant, and cotangent. As soon as you get secant, cosecant, and cotangent, as soon as you get one of those isolated, the first thing you do is you apply the reciprocal. If two numbers are equal, when you form the reciprocal, these are still equal to each other. And so the reciprocal of secant, this immediately implies when you form the reciprocal of secant, the reciprocal of secant is cosine. This is 1 over secant, the same thing as cosine. That's the reciprocal of the left. The reciprocal of the right is 1/2, and now we're going to solve this equation. The solution to this equation is the same as this, and this. So now we're back to our process from our previous videos. We want to solve, this is now a basic equation. So if you have secant, cotangent, and cosecant, you isolate it and then form the reciprocal. So that's another sort of principle to watch for. Now solving this is one of the special angles. So now we're going to deal with our triangles here. We have 1, 1/2, root 3 over 2. And we can see the 1/2, we know that's the triangle we want to work with. So it's 30, 60, 90, but since we're in radians, that's going to be pi over 6, pi over 3, and pi over 2. And so now we're doing the same process as before. Quadrant check, reference angle. Quadrant check. All we want is when is cosine positive. When is cosine positive? Cosine is positive. Cosine is positive in quadrants 1 and 4. So we have a quadrant 1 solution, quadrant 4 solution. And so we're done when we find those two numbers. Once we've done the quadrant check, the fact that this is positive or negative is totally irrelevant. All we're looking for is the 1/2. We want cosine because we know cosine is adjacent over hypotenuse. Either this angle, adjacent over hypotenuse, is equal to 1/2, or this angle, adjacent over hypotenuse, is 1/2. And is it pretty clear? We just try one, see if it works. Try this. Adjacent, no, this is a radical 3. We don't want that. We want cosine adjacent over hypotenuse to equal 1/2. Here, this angle, adjacent over hypotenuse, is 1/2. That's the angle we want. Even though it's 60 degrees, we know that's pi over 3 radians. So that's the reference angle. We have x reference is pi over 3. Pi over 3 in quadrant 1 as a reference angle. Well, reference angle is the same as the angle in quadrant 1, pi over 3. And in quadrant 4, we know what that is. If this is pi over 3, that's 2 pi subtract off 1 pi over 3. So that's 2 pi subtract off pi over 3. 6/3 minus 1/3 is 5/3. And so that's our solution. All right. So let's see if we can throw number 20 up here. Number 20 says, we have secant squared. So we're going to practice our secant, changing it into cosine process again. Secant squared of x. It says plus 2 rather, equals -1. Secant squared. Secant squared plus 2 is equal to -1. All right, so we're going to isolate. So we get secant squared of x is equal to -3. Is it clear we can take the... So, when we want to solve these equations, we don't want secant squared. That's not the basic equation. We want just secant. If this were sine squared, we would want just sine. If this is tangent squared, we would want just tangent. We want first power exponents, so that becomes a basic equation. Well, one of the ways to do that is to use the square root method, take the square root of both sides of this equation. So we would say the square root of secant squared of x is equal to plus or minus. Remember, whenever you take the square root of both sides of an equation, you must introduce the plus or minus. And the problem here, I think you can see, is for our purposes, since we're limiting ourselves to the real number system, there's no solution here. All of our work is limited to the real number system. So this would give us that. This would give us secant of x is equal to plus or minus square root -3, but there's no solution. Remember that, and you'll really live this if you go into the calculus sequence. You need to get out of your mind that no solution means no information. No solution is not a waste of time. No solution is not no information. No solution means whatever it was you're looking for, there isn't one. We're trying to find the solutions to this equation, and what it says is there is no solution to that equation. When you get into the calculus sequence, that starts to gain quite a bit of currency. For us, for now, no solution, because the square root of -3 has no solution. If this had been +3, then we'd been in a different kettle of fish.